Okay, for example 2, very much the same question that we have. Let's just say a sub n is equal to n all over 2n times n plus 1. And of course, we look at that and we think, oh, nuts. Maybe I'll try an nth term test. Actually, as you think about it with n behavior, the n and the n plus 1, the n plus 1 would more or less be like an n. They would cancel out, and you'd be left with 1 over 2 to the infinity. Hey, that's approaching 0. Good try, but it's further investigation needed. Let's talk about b sub n. B sub n, this is where we need to create a new series, preferably one where nice things can happen and we can know whether our series converges or diverges. So as we're looking here, look to the original form and say, oh, if only I could, take something away or, change something to make it a simpler type of a problem. There are two different perspectives you could have here. Does anybody have an idea as to what might change and help us cancel out and have something simpler? Take out the n plus 1, change the n plus 1 to maybe just an n. You see what I'm getting at? Other kids might say, ooh, add a 1 up on top. That would accomplish the same thing, wouldn't it? What really just happened? I made my denominator get smaller. I made my denominator get smaller. Now, when your denominator gets smaller, that overall fraction becomes bigger, right? Think about it, moving from 1/3 to 1/2. 1/3 of a pizza compared to 1/2 of a pizza. Your smaller denominator represents more, doesn't it? So, wow, you could even say at this point that our b sub n is going to be larger. But look at this. These n's cancel out, and you'd be at 1 over 2n. So I could say, comma, b sub n, of course, is bigger than a sub n. Our denominator got smaller. Our new fraction is bigger. But take a look. You can say consider, or you don't even have to write consider. Consider this thing. Is it a p-series? No. Doggone it. Is it something else that we might recognize? It's geometric. Wow. And if you need, by the way, when you see, guys, when you're seeing an exponent of an n like that, and you could even begin to work it out, plug in a 1, you'd be at 1/2 to the first, plus plug in a 2, you'd get 1/2 squared, and so forth. I think you can quickly see that your r here would be 1/2. So is this a convergent geometric series or a divergent? This is convergent. Consider this, which is a convergent geometric series. Because your r is less than 1 in absolute value, right? Well, right now, the series that we have just created levels off. It flattens out. It's going to converge when you look at its partial sums. And a sub n is actually below it. What picture do we have here, the first or the second? The first. You can see the one we created is in blue. It's going to level off. It's going to converge. But a sub n is always going to be smaller. I don't know what it's going to flatten out towards, what it will converge to, but it must converge. I can say by the basic comparison test, this original series converges also. What's the key to today's lesson? Look for hidden p-series or hidden geometric series. Make adjustments to your numerator or denominator so that you can find those. Then you'll quickly be able to say, hey, I can compare the two fractions. I'll know which fraction a sub n or b sub n is bigger, and I'll know whether b sub n converges or diverges. Like we said earlier, though, sometimes the directions of the inequalities aren't going in the right order. Look, we just did Roman numeral 1. If A sub n was actually larger than B sub n, if the red stars are above the blue stars, maybe the red stars flatten out, or maybe the red stars launch off towards infinity. In that case, we wouldn't know. So listen, guys, sometimes it's also super difficult to find a new series. Let's look at the next page, the limit comparison test. Let's say that we have two series, they're positive, and there's a positive real number c such that the ratio as n goes to infinity of a sub n over b sub n is a real number c. Of course, it would have to be a positive number if a sub n and b sub n were both positive. If you get some positive number, not 0, it's got to be bigger than 0, then either both series converge or both series diverge. Wonderful. This is called the limit comparison test. Take a sub n and b sub n, make them into a fraction. Divide them. Have the limit as n goes to infinity. If you arrive at a number like 7 or 1/2 or whatever it may be, the behaviors will be the same for the two series. So once again, the key is choosing b sub n so that we get a friendly p series or a friendly geometric series. Let's read this hint. If a sub n has a quotient, then to determine b sub n, delete all terms in the numerator and denominator except those that have the greatest effect on the magnitude. Think end behavior. Think end behavior. Look, as you look at some of these problems, you can see the complexity grow. Do you see how sometimes you might have multiple terms on top and down below, and sometimes kids wince a little. They'll be thinking, wow, doing basic comparison tests, I'd like to make my numerator get smaller, and then I'd like to make my, losing that +1, and then I'd like to make my denominator get smaller. You're working in the same direction. That gets confusing. Instead, think n behavior. What controls the top? 3n. What controls the bottom? 4n cubed. Oh, would you look at that? This is a p series. That's 3/4 times 1 over n squared. Hey, I'll work with that any day. And then we come over here. Sometimes kids are like, yikes, we've got a radical here? Oh my gosh, does that look horrific? Well, what controls the top? Clearly, 5. What controls the bottom? The square root of n squared. What is the square root of n squared? Remember, n is positive. Normally, you'd say absolute value of n, but because n is positive, doesn't it just become an n? It's a harmonic series. Or a p series, if you'd like. I mean, the harmonic series fit into the p series. That thing diverges. Wow. All of a sudden, you look at this monstrosity. You're like, oh my gosh. Like, cube root of n squared plus 4. Holy cow. What's controlling the top? N to the 2/3. Yeah, good. Cube root of n squared or n to the 2/3. Either way. Down below, what's controlling that thing? 6n squared. So yeah, we might have to do a little cleaning up. It's okay. And wow, then, sometimes kids would be like, I remember in Algebra 2, we could subtract, that's like 2/3 minus 6/3, and that's 2/3 minus 6/3 is negative 4/3. So you'd say this is n to the 4/3 down here. Hey, that's a p series too, isn't it? If I put a sigma in front of it, right? And would that p series converge or diverge, guys? It would converge. If your power is bigger than 1, then you converge. If you're smaller than 1, then you diverge, right? All right. Well, with no further ado, let's see where we're going here. I guess we've got, a couple more problems. Here's your a sub n. Help me out, guys. What's b sub n going to be? What's the top? 3n. What's the bottom? N cubed. Good. What do we get? This is really 3 over n squared. Which, hey, that's a p series, isn't it? Help me out. Converge or diverge? Converge. It's going to converge. So if the limit comparison test works, the behaviors are always identical. What I want to point out to you is the series either both converge together or they diverge together, but what is the condition you have to check? You got to take this limit. You got to say, I'm going to take the limit as n goes to infinity of a sub n over b sub n. And you'd say, well, that is maybe not the prettiest looking thing. Look at this ugly thing right here. Dividing by b sub n is the same thing as multiplying by its reciprocal. Listen, you could write this out right here. You could show that, literal division. You want to save yourself a little bit of space. You could just cut to the end and say, you know what? I know at the end of the day, I'm ultimately going to be multiplying by that reciprocal. You might have heard me talk about why BC focuses so much on n behavior. Your friends in AB probably don't do that as much. That's because we're going to use n behavior every day now. Big time. Big time, right? And you're going to look right here and you'd say, what controls the top in this expression when you multiply everything out? 3n cubed, right? We get 3n cubed. What controls the bottom? 3n cubed. Guess what 3n cubed over 3n cubed is? 1. Ultimately, you've got a 3n cubed over a 3n cubed. That thing's just going to wipe out to a 1. Did we meet the conditions of the limit comparison test? It's greater than 0. You bet we did. So here's what we can do. We can say that b sub n in a series is a convergent p series by the limit comparison test. The original series for a sub n, and you could even write a sub n in there if you want to save yourself a little writing, converges also. Okay? The behaviors are the same because that limit is a real number other than 0. It's a positive real number greater than 0. Okay? Last one. Here we've got a sub n. Kids are probably like, oh my gosh, would you look at this thing? Yuck. Yeah. Help me out. What do you think we're going to have for b sub n, guys? 1 over, radical n squared, which, thank you so much, isn't that really 1 over n? Kids would be like, oh, sure it is. And that's a harmonic series. Way to go. Way to go. Tell me about the harmonic series. Does it diverge or converge? Which one? Absolutely. The most famous divergent series of all. We will reference it practically every day. So real quickly, kids are going to say, okay, so I know that thing diverges. Wow, if only this thing could be figured out too. Listen, I'm all about simplifying matters, and I'm so thankful that you guys saw that it's 1 over n. But dare I say, sometimes it's, with radicals, especially more helpful to maybe take a step backwards and call b sub n 1 over the square root of n squared. Sometimes kids are like, really? Yeah, because look, I'm going to multiply by the reciprocal, guys. I'm going to multiply by the reciprocal. I think you can see where we're going. And now I'm going to say, hey, why not just make that 1 radical? Right? If I've got the square root of n squared all over that other stuff, couldn't I just make it 1 nice radical of that fraction? N behavior, where's this thing going? 1. What's the square root of 1? 1. And that's greater than 0. So I could say b sub n is a divergent harmonic series By the limit comparison test, this thing diverges also.